You ever find yourself sitting in a window seat looking out at that enormous wing and just think, how is this possible? How does this massive metal tube stay up in the air? Well, today, we're going to break down the simple, honestly elegant science that keeps these giants flying. I mean, seriously, think about it. A machine that weighs hundreds of tons, just cruising miles above the ground. It feels like it should be impossible, right? Like it's defying gravity itself. But it's not magic, it's physics. And it all starts with one very special, very important shape.
And yeah, you guessed it, we're talking about the wing. But it's not just a big, flat board sticking out the side of the plane. The very specific, carefully designed shape of the wing is the secret ingredient to the whole recipe of flight.
So if you were to slice a wing open and look at the cross-section, you'd see this shape. It's called an airfoil, and it's the absolute secret sauce here. Notice how it's kind of curved and thicker on the top, but much flatter on the bottom. That difference isn't an accident, it's everything. It's specifically designed to force the air that hits it to go on two totally different paths, and that is where things get interesting.
Now this magic isn't some hocus pocus. It's all about something invisible that's all around us right now, air pressure. And it turns out that airfoil shape is a genius at manipulating this pressure to create an incredible upward force.
The science behind all this has a fancy name, Bernoulli's Principle. Now I know, that sounds complicated, maybe something you'd hear in a physics lecture. But the main idea, the part that actually matters for us, is actually incredibly simple. It's all about how fluids, and yes, air counts as a fluid, behave when they move.
And this right here is the golden rule. It's pretty much all you need to remember. Wherever air is moving faster, you get lower pressure. And wherever it's moving slower, you get higher pressure. That's it. This simple little inverse relationship is the engine that drives the whole phenomenon of flight.
Okay, so let's put it all together. The plane starts moving forward, right? The wing slices through the air, and the air splits to go over and under it. Because the top surface is curved, it's actually a longer path. So the air on top has to speed up to meet its buddies at the back of the wing at the same time. And what did we just learn about fast-moving air? Yep, it creates low pressure. Meanwhile, the air under the flat bottom moves slower, which means, you got it, higher pressure. Nature hates that imbalance. So that high pressure underneath literally pushes the wing up toward the low pressure area. And that push, well, that's lift.
But hold on, Bernoulli isn't the only one at this party. The legendary Sir Isaac Newton has something to say about this too. You know how wings are often tilted up just a little bit? Well, as the wing moves, it's actively pushing air down. And Newton's third law tells us that for every action, there's an equal and opposite reaction. So as the wing pushes air down, the air pushes the wing up. It's like a 1-2 punch that contributes to that incredible upward force.
All right, so we've pretty much cracked the code on lift. But lift is just one piece of the puzzle. To really understand how a plane stays so stable up there at 30,000 feet, we have to zoom out and look at the four-way balancing act that's always going on. Think of it like a constant cosmic tug-of-war. These four forces are always fighting each other, and a pilot's main job is to manage this incredibly delicate dance to control where the plane goes. And here's the breakdown. You've got a vertical battle. Weight, which is just gravity, is always trying to pull the plane down to Earth. Fighting against it is lift, pushing the plane up. Then you've got the horizontal battle. Thrust from the engines is blasting the plane forward, while drag, that's just air resistance, is trying to hold it back.
So it's all about which force is winning at any given moment. If you want the plane to climb, you need to generate more lift than the plane's weight. It's that simple. To descend, you reduce lift so that weight takes over a little. And to just cruise at a steady altitude, lift and weight have to be in perfect balance.
But here's the thing. You don't get that lift for free. You need air to be flowing over those wings and fast. And that is where those massive engines come in. They create the incredible forward push, the thrust, that gets the whole plane moving fast enough to force air over the wings and let them do their lift-generating magic.
Which leads us to something we've all seen. Probably without even thinking about it. Why on earth do these huge planes need such ridiculously long runways to take off?
Because it all comes back to that tug of war. That runway is basically a racetrack. The plane is flooring it, using all that engine thrust to build up enough forward speed. It has to go so fast that the air rushing over the wings finally generates a lift force that's strong enough to overcome the entire weight of the plane. Only then can it finally leave the ground.
Okay, so we've covered the wing shape, the principles of air pressure, and that constant four-way battle in the sky. Let's boil this all down to one single, simple takeaway.
At the end of the day, what's keeping a 500,000-ton machine floating in the sky isn't 100 different complex things working at once. It really boils down to one beautiful, elegant principle of physics that the wing is built to take advantage of.
And this is it, the whole story right here. The special shape of the wing makes air go faster over the top. That fast air creates low pressure. The slower air below has higher pressure, and that high pressure pushes up. That simple push, multiplied over the huge area of both wings, is what lifts a plane into the sky. So the next time you're on a flight, looking out that window, you'll know exactly what's holding you up there. It's not magic. It's just really, really cool physics.